take a look at how to leverage Desmos to solve systems of equations and when to do it. When you're teaching students that are in the middle to high school level of math, there's content, there's testing strategy, and then there are testing topics that you have to kind of juggle as a teacher to balance. So if I was living in my perfect world, the way that I would approach the system, because one of them has a quadratic term and one of them does not, the way that I would approach this is by hand. We would solve the second equation for y, and then we would plug that into the first equation. So basically this would become 3 times whatever that equation is. And it takes, a good solid 5 to 10 minutes to execute that question. Now, the challenge is that as a teacher, my students aren't going to have 5 to 10 minutes on this question. This is an ACT level question, and they're given 1 minute per question on the ACT to solve questions. There's similar timing across the Texas STAR test for this topic. So most schools provide a handheld calculator, or the testing system provides Desmos. So when I introduce this, I do introduce this topic by hand for my high school students. But however, once I feel like they have a good grasp of substitution, then I show them how to do this in the actual Desmos, because they won't have time to do it by hand. So I have to juggle. I want them to understand what they're doing with, I also need them to succeed on their tests so they can go to college, so they can pass the grade, whatever the high stakes requirement is. So in order to solve a system of equations using Desmos, you're simply going to enter the equation in. So I enter 2x squared plus 3x equals 7. I don't even have to solve it for y. I can enter it directly in there. I'm going to do the same thing with my second equation. The answer to the system of equations is where the lines intersect. So if you see these gray dots are highlighting important points in the graph. So here I have my x-intercept. I have my y-intercept for my line, and you're also going to notice this point and this point, which are both the intersections of the parabola with the line. So the solution to the system of equations is x equals negative 3.2, y equals negative 4.6, x equals about 2, and y equals negative 0.4 or negative 0.39. That's the solution. So you can see there's a big difference in how fast I can do some of these problems, but the key is they still have to understand that they're not looking for the x or the y-intercept. They're looking for the system where they cross, and because it's a quadratic and a line, it's going to happen twice. So there's going to be 2 x answers and 2 y answers that are matched as a pair. Now, doing this for a regular old system of equations, let's see. If I have 2 linear system of equations, it's kind of arguable. Graphing this is going to possibly take longer than just solving it by elimination. So in these cases, I don't always advocate for my students to graph it, because sometimes, especially if it's not in the right graphing window, so if you can't see the intersection, so for instance, let me just make this something like really big here. So if this was like 50, I would graph this and I would say, well, I only see one line. That's a problem. I have to find the other line. So I'm going to be dragging my screen around trying to figure out where that other line is. That's why I say in cases like this, a lot of the times I'm going to tell my students, just go ahead and do substitution or elimination, and that way you're not trying to find it on your screen when you've got 2 lines. However, if I have 2 lines, I can graph those in Desmos, and I can get the solution. So the solution would be 3.6 and roughly 0.9 for y. So that's how you're going to utilize Desmos to help your students, and you always have to juggle teaching them the understanding of something, but also teaching them the strategy, because they have such limited time on those high stakes tests to be able to implement a full mathematical process.